this one, MQT14. MQT14 is terminal strength test. And for this test, the purpose of this test is when during transportation and installation of the PV panels, the cables in the junction box may be subjected to stress, and it is very necessary to determine whether the lead-out terminals and the connection between the wires and the panel body can withstand the force encountered during normal installation and operation. This one it's a multifunctional equipment which you can conduct tensile test and torque test and the bonding test within the same equipment. Now we're here at MQT15. MQT15 is wet leakage current test, which this one is one of the must-do tests in the production side. When solar panels are exposed to different weather conditions, such as rain, fog, or melting snow or moisture, these may cause moisture to penetrate the working parts of the internal circuits of the panels. So this wet leakage test system is designed to verify the insulation performance. The insulation performance of the solar panels. This one will pair with our high-pot tester to check its insulation performance. And the temperature range of this equipment which Millennial Solar provides is from 15 to 25 degrees Celsius, and its accuracy is 0.1 degrees Celsius. And this one is a very simple but effective device, and this one is very affordable. Under MQT16, and MQT16 is static mechanical load test. And for mechanical load test, there's two types of different tests, which there's one static and there's another one dynamic mechanical load tester. And the mechanical load tester is to evaluate whether the parts and components within the module are affected to low level of mechanical stress. Yes. Because the installation process can compromise the intactness of the module. And for this device, we have several different versions, and the suction cups can be we offer two types, and one is 72 cups, and the other one is 84 cups. And you compare with the same amount of cylinders, or you compare like one cylinder with the 4 cups. And its uniformity, because for mechanical load tester, its uniformity of the load is very important. And in this machine, we can got the uniformity control within plus and minus to 2%. And each channel can be independently controlled. I mean, the force can be independently controlled. And now we come to the static and mechanical load. Yes, this one is much more simpler, and the same purpose. The purpose is to check if the solar panels can subject to low level of stress, and its logic is a little bit different than this one, the mechanical load, the dynamic one, because this one is using a cylinder to give the force, to apply the force, but this one is a static one. We use sandbag, which I will show you a little bit later on in our laboratory. It's just applying sandbag on top of the solar panels. Yes, and this one we also equipped with the temperature and deformation and the current monitoring features. And of course, you can check the real-time curve display as well in its monitor. MQT17, and this one is hill test. So the purpose of the hill test is that There are situations when solar panels can be damaged by natural diseases, such as hail, and during the outdoor actual use. And ice balls of various diameters are launched through. Okay, so this is actually the principle of this hill tester that we designed. And for this hill tester, we have a different types of mold which can make different diameters of the ice ball to give pressure and the heat on the surface of the solar panels to verify the load bearing stress of the solar panels. And the accuracy of the sensor is plus and minus to 2% for this one. And its positioning, it can be automatically set. Now we come to MQT18, bypass diode test. So during the long-term use of the panels, and due to inconsistent alternation performance of each of the individual cell or surface shadows, the situation will cause electrical performance of some cells be inconsistent with others. This will result in a hotspot effect, which will affect the thermal performance of the bypass diodes. And we use this bypass diode thermal tester to verify its thermal performance and thermal runaway and functionality of the diodes, just to ensure it is efficient. It will be efficient for the operation of the whole system. And what's special about this device which Millennial Solar provides and is that the software, the test software can automatically fit a voltage difference versus the temperature of the junction. We can do a automatic fit, and we're allowing the real time online viewing of the test data. And of course, and you can also check trace back to the historical data as well in this device. Now we come to MQT21, potential induced degradation test. So what is potential induced degradation test? So basically, you will need a device to simulate the potential leakage current between internal conductors and the ground in the module to evaluate the NT-PID capability. Just to ensure it is stable for long-term operation. And this one you have to pair with the chambers because they have a requirement of STC. And so this one you need to pair with the humidity, the damp heat chamber. And its voltage current accuracy can reach to 0.5% fs. So we have finished all the test sequence and process under IC 61215. And of course, some tests under IC 61730 is also very important because this category is for the manufacturer to approve their product is safe enough to enter the market. So basically, what kind of equipment will be used under the IC 61215 testing procedure? Of course, there are some similar equipments with the IC 61215, like the chambers, the TC chamber, humidity freeze chamber, and damp heat chamber, and same as some mechanical testers. But what's different is there are some small devices, we have the accessibility tester, and we have the sharp edge tester, and insulation thickness tester, an impulse voltage tester, and a reverse current overload tester. And these are a little bit different from the previous one, X6 1215. So now we are looking at ground continuity test system. And so the grounding continuity test basically is to check that a reliable conductive path is formed between the metal components of the module, such as the frame, the bracket, a junction box, etc., and the grounding system. And you can quickly conducting the lining current into the earth and reduce the risk of the module to burning. Accessibility tester. And for this tester, a very simple tester, and this basically is to simulate a finger. Yes, the contact tester. This tester simulates a human finger under conditions of a certain voltage and inside and outside, and test the risk. They identify the risk of electrical shock at accessible locations, and its resistance range is from 0.1 megaohm to 10 gigaohm. Impulse voltage tester. So the impulse voltage tester basically is to simulate the impulse voltage tester basically is just the device to simulate the over voltage conditions, such as lining strikes and switching surges that PV modules may encounter in the actual use. By measuring the relevant electrical parameters, it is determined whether the internal materials such as encapsulation film and the back panel and the circuits of the module can withstand such extreme voltage shocks. This will help to resist transient overvoltage, ensure systems reliability, and meet the international access requirements. Reverse current overload tester. And this reverse current overload tester is designed to identify any fires or ignition that may occur in the real situations, and as well as other situations where the panel can be damaged due to overheating. Okay. Source spray chamber. So for this chamber, basically we are just simulating a salty environment and to check the panel's resistance level of the salty corrosion chemicals. And in this chamber, its temperature tolerance is plus and minus 2 degrees Celsius. And its humidity range can be set from 20% to 98% relative humidity. Module breakage tester. And for this tester, it's a very traditional and basic mechanical tester. This one is to test the machine. This machine is used to verify the quality of the polymer or the surface material used in the solar panels, and as well as the potential for damage to personnel and after a breakage. An EL tester. The EL tester transmits this radiation to its high definition camera, and which captures an image of the cell within the module. And based on this image, microscopic defects within module can be detected, and this will allowing analysis of product defects in the cell or module. And the resolution of the camera we equipped within this EL is 6,000 times 4,000. And its exposure time is adjustable. It can adjust from 0 to 30 seconds.